In this video, I'm going to cover the overarching concept of the runoff risk assessment, and then the two tools that are associated with it, the D8 distance to stream tool, and then the actual runoff risk assessment tool, which ranks fields based on their susceptibility to runoff. The runoff risk assessment uses two variables to classify agricultural fields by their risk to direct surface runoff. The first variable is slope steepness, which we'll get by using the by-field slope stats that we calculated earlier. And then the second is stream proximity, which is actually converted to a sediment delivery ratio. We'll get this value by running the distance to stream tool. The fields are given a rank of either high, medium, or low based on these two variables. So to get our stream proximity measure, we need to run the D8 distance to stream tool first. This tool calculates the horizontal distance in meters to the stream reach from each grid cell, moving downslope according to the D8 flow model until a stream grid cell is encountered. Alright, so we're in our map document and we're ready to run the D8 distance to stream tool. So we'll open it up and it looks pretty simple. We've got two inputs, our stream reach and our flow direction raster. And then our one output is going to be the distance to stream raster. So we come over here and grab our stream reach, drag it in. Flow direction is automatically added. Our output is going to the right place, so we hit OK and let it run. Alright, so it's just finished running. We'll close this. And we can see it's been automatically added, but let's give it some color to make it stand out. So I'll give it, let's see, this color ramp. As I always do, I'm going to change it from current display extent. It's on % clip, which is happy. Hit apply. Okay. And then I'm going to invert this because closer to stream makes sense for me to be blue. And now I can see my distance to stream raster, where the darker blue parts of the raster indicate that we are close to the stream. And then the further away it goes, the more of this orange to burnt red color it turns. Now we'll move on to the runoff risk assessment tool. I want to take a quick look at the tool interface so you can get an idea of what's actually going to be put into it. So first it asks for our field boundary feature class, and then it asks for the slope table. And it needs this because this is what it will use to get that slope steepness variable for each field. The third input is the distance to stream raster, which we just developed, and it'll be using this to develop that sediment delivery ratio, which is essentially the stream proximity variable. We then have these different break values that we can set for both of these variables. These first two have to do with slope. So what is the threshold point for the high third quartile slope value? What is the median value? You can see that these are optional. You don't have to include these. And then similarly, we have our high threshold value for the sediment delivery ratio, and then the medium threshold value for the sediment delivery ratio. Again, optional. If you do not include these, then it is going to be automatically split into a 20, 40, 40%. I'll go into more detail about this. So the first variable of the runoff risk assessment is stream proximity. And so values from the distance to stream raster will be converted to a sediment delivery ratio, and this is going to represent that distance from each edge of the agricultural field. This has a range of 0.17 to 1. Where distances less than 10 feet are converted to a sediment delivery ratio of 1, indicating that they're very close to the stream. And distances that are 5,000 feet or greater away are converted to a sediment delivery ratio of 0.17. So if you were to set those breaks, you would definitely want to set it in between this range, where if you set the high threshold value, it means that that value to 1 means a high sediment delivery ratio. When you set the medium value, it is that medium to high value, and then anything below that will be 0.17 to that medium value, and that'll be a low sediment delivery ratio since it's very far away from the stream. As I said before too, you can just leave those blank and they will be automatically generated, broken down into that 20-40-40 split. The second variable to the runoff risk assessment is steepness. And this is going to use the 75th percentile slope for each field, and that comes from the slope table. The two images below show the difference between allowing the tool to automatically generate thresholds of slope compared to when the user defined thresholds. So although it's kind of difficult to convert sediment delivery ratio to the numbers to actually mean something to the user, people generally understand slope. And you may know for your watershed that slopes 8% or higher are much more at risk compared to other ones, or maybe 10% or higher. We can see here that if we let the tool automatically break it down, that slopes of just about 5% or greater were considered to be at high risk, where in reality that's probably not the case. So for the steepness variable, it may make more sense to actually define which is your high and medium threshold value. Alright, so we're back in our map document and we're getting ready to run the tool, but before I do that, I want to take a look at my slope table just to get an idea of the slope characteristics of each field within this watershed. So I know the tool uses the 75th percentile slope, so this will be the field that I want to focus in on. I'm going to right click and choose statistics. And this is just a quick breakdown of each value so I can see that the mean by field 75th percentile slope is this 5.67, and that my minimum value is 0.62, so about 1. My maximum is this whopping almost 37% slope. And then I can also take a look at my histogram over here, and I can see that a majority of the fields are falling right around this 6% slope. So this just gives me an idea of what a steep field may look like in this field, or what a flat field may look like. So I can close that, close this, and now I feel more comfortable running this tool and making some decisions. So first, we'll drag and drop in that first input. You can see our slope table and our distance to stream are automatically added. And then, as far as the decision making here, I am going to choose a value for these. You can leave them blank and it'll automatically break it down, but since I took a look and I kind of understand what's going on, I'm going to choose to have 8% be my high threshold value, since the majority of the fields were below this, and then for my medium I'm going to put 6%. And I just feel like this will represent my watershed a lot better than maybe the automatically generated values. I am going to leave the sediment delivery ratio thresholds blank to let the tool automatically develop those. And then the one output we're going to get is the runoff risk table, which has been automatically populated and is going to the right place. So I hit OK and let it run. Alright, so the tool is just finished running and my runoff risk table has been automatically added to my table of contents. So what I'm going to do now is join it to my field boundary feature layer. If we take a look real quick at the table, you can see that it has that field boundary ID field, which will allow me to join it. So let's go ahead and do that. Join, join. Make sure that you are on your runoff risk table. We're always going to join by that field boundary ID. Hit OK. And then we can go into symbology, go into categories, and start to symbolize it. You can see we have quite a few new fields to choose from. For this case, I'm going to choose to symbolize it by the actual runoff risk rank. So I add all values and do some symbolizing. Okay. And we get a value of critical. These are the fields that are at most risk for runoff. Then we have very high, which is the next step down. Then we have high, which is the third step. Go with that, okay. And then we have this final field, present. That's because runoff is always going to be occurring in a field, no matter how small the value is. We don't want to say that no runoff is ever occurring. So we have this, all values now coded. I hit apply, okay. And now we can see across our watershed what fields are at more risk than others. And it makes sense when we initially are looking around that the fields closest to the stream tend to be at higher risk for runoff. If we open the attribute table again, and we slide over to look at those values joined by the runoff risk table, we can see that we actually get the individual ranks for the slope and that sediment delivery ratio. And these will have been based by those thresholds. So for the slope, I know that any 75th percentile slope that is above 6 is going to get that medium rank, where then any value that's above 8 is going to get a high rank. So we have for mediums and only 2 highs, and we have one field that's 8.7 and one field that's 10.25. All these null fields here are non-agricultural. And then we actually get an adjusted distance to stream, a distance to stream value for each field, and then a sediment delivery ratio value as well. So if you looked at these sediment delivery ratio values and got an idea of what each field was like, you could actually rerun this tool with your own threshold specified for the breakdown of that sediment delivery ratio. Here's a brief recap of the 2 tools that we just ran and about the concept of the runoff risk assessment.